Hello. Next we look at reflections. A reflection in line M maps every point P to P prime, such that if P is not on the line in the line M, then M is the perpendicular bisector of the line segment of P prime. So for example, this is line M is the mirror. Reflection will always have a mirror. It's like to flip over. So if this is the mirror, line M, and this is point, P represents point, so B is a point here, is not on this line, then this, see, the B and B prime, they are image of each other. So this line segment is going to be perpendicular to this line of mirror. So the same thing, line A prime, segment A prime is going to be perpendicular to this line, also C prime. But if the point is on the line like this one, so y-axis, okay, this line, black line here, is the mirror. So this point that connects, that is right on the line, is going to be exact same thing both for the image and for the pre-image. It is not going to change, but the other points here and here will change. Okay, that's what that is saying. Again, we write the expression, the notation, as reflection in line M maps P to P prime. Okay, that's what a reflection in line M maps P to P prime. Or we can write it with notation, but it read the same thing. Or P is reflected in line M to P prime. All right. Well, we remember that reflection is isometry. We name three of them: reflection, translation, and rotation. Isometry. So that means they are invariant. They preserve distance, angle measure, and area. So these things they preserve are invariant, means they don't vary. They remain the same under reflection. So however, there is something that varies, the orientation, because the orientation can change, and since the orientation can change, the slope of their segments can also change, but the length of the segment does not change. So keep that in mind. Now, classify this as true or false. A reflection preserves angle measure. It's true. A reflection preserves segment length. So segment is a distance. Answer, true or false? I hope you said true. A reflection preserves orientation. Okay, we just saw that one. False. It doesn't preserve orientation. A reflection preserves the slopes of lines. Well, what happens to the slopes if the orientation changes? It's not going to change too, so it's false. A reflection preserves the area of polygon. That's true. Okay. Okay, draw the mirror line X equal this. So, and then reflect the shape under the line. So first of all, we draw a line where X is equal to -1. So let's use a different color for this, maybe color blue, well, red. So this is -1 when X is -1. This is line X and this is -1. So draw a line, there, and draw here. So this is line X. This is line X equals -1. Okay, so we're going to reflect this image on this line. So the line of reflection, first of all, you have to count the distance, or first of all, identify each of the points, and then you reflect each of the points. In case of complicated image, just reflect each point. So this point here is 1, -1. So how far it is from this line of reflection, this mirror? So from this mirror, we go 1, 2. We go 2 steps to get there. So from this mirror, we're going to go the other way. 1, 2 to get that point. So we put that point there. And then this point, we go from the center, from the line of reflection again, we go 1, 2, 3, 4. It took us 4 steps to go there. So we go back the other way. We go 1, 2, 3, 4. There we have that, and then we connect those 2 points. That's our first. And then here, from this point to that's gonna go, you go down 1, 2, 3, 4. 4 steps. So it's gonna go down 1, 2, 3, 4. Okay, and then this point is like 1, 2, 3 steps away. So it's gonna go 1, 2, 3 steps away. So it's gonna be here. And then we connect it to the same thing here. We can see the pattern now. Once you catch the pattern, you can just complete it. If you are not sure, just trace it or get the point. Okay, that's it. That's the mirror image on this line. The distance from here to here has to be the same. So what if you are to reflect it on the x-axis? Just let your x-axis is going to be your mirror. So you go, this point is just 1 unit away from x-axis. So you're going to have it there. And then this point is like 1, 2. And then so you're going to go 1, 2. And then we have it. Again, this is gonna go again 4 units. You're gonna go 4 units this way. 1, 2, 3, 4. And then here, this point, you're gonna go 1, 2, 3. So you're gonna go 1, 2, 3 to get that point. Then we connect it here. And again, we can see the pattern now and complete it. That's it. Okay. So basically, whenever we are reflecting, reflection is one of the easiest transformation to do. Identify the line of reflection, your mirror line. If it is x-axis, keep the x coordinate the way it is, and then change the sign of the y coordinate. If your mirror line is y-axis, keep the y coordinate and change the x. If your mirror line is this line, y equals x, then switch y and x coordinates and keep them their signs. If your mirror line is y equals -x, switch the y and x and then change their signs as well. So here, find the pre-image of -7 and 5. So here 7 is the x, -7 is x, and 5 is y. Oh, don't mind this. So to find when this is reflected in the y-axis, what happens? So we're going to keep the y, this is reflected in the x-axis. So we keep the x value the way it is, which is -7. And then we are going to change the y as -5. My pen is horrible. Okay, if this is, it is reflected in the y-axis, it means we keep the y coordinate. The 5 is the y coordinate, so we keep it. And then we are going to change the x to +7, and then keep the y as 5. If it is reflected in the line of x and y, we just switch x and y, so x becomes positive 5 and y becomes negative 7. And if it is reflected in the y equals negative 7, we switch 5, we switch it, but then we change the sign, so it becomes negative 5. And then negative 7 becomes positive 7.